This is a presentation of CPCI, the Center for Pharmaceutical Cleaning Innovation. This presentation will discuss utensils and ancillary equipment, the risks that are associated with them, and whether they need cleaning validation and/or dedication. Here we see a scoop and a diagram of a Patterson-Kelly type filler and a diagram of a shaker box type filler. So let's say we weigh up some active ingredient of A, and we would transfer that into the blender, and in the processing we would get residues of A on the blender, and that would eventually go to the filler, and we would get residues of A on the filler. Now we want to calculate limits for cleaning. So we would take the ADE of A, and we multiply that by the batch size divided by the maximum daily dose of some other product, B for instance, and that would give us the total number of doses in a batch, and multiplying those two together would give us our maximum safe carryover. So let's plug in 0.1 milligrams of A and multiply that by a 5,000 kg batch, and let's say a 1 gram maximum daily dose, so that'd be 100 milligram tablets and maybe 10 of them during a day maximum, and that would give us 50 milligrams as our maximum safe carryover into the next batch. So that number would plug into this equation here, and we would have 50 milligrams divided by the total surface area would give us a safe residue level per square centimeter. Now we have the values for these pieces of equipment, and we'll put them in here, and that will give us 50 milligrams divided by 45,100, which will come out to our safe residue level of 11 micrograms per square centimeter. Note that we added all the surface areas together, which is common in the industry, and we even left out quite a few pieces of equipment like the tablet press, intermediate bulk containers, and some other things that may have touched the equipment in the processing stream. So that limit of 11 micrograms would be much lower. Now we clean everything, and we want to use the scoop for something else, another line. Is that a problem? Should we dedicate that scoop to that line? Well, if we weigh product B in there, why would we add all that surface area from this other equipment into the limit for that? We really are only concerned about the surface area in that scoop, because that's the only area that product B is coming in contact with that could continue through and contaminate the next batch. So this calculation doesn't apply to the scoop if it's being used for another line, meaning it's not dedicated. And this calculation would change from 45,100 down to 50 milligrams divided by 100 square centimeters, which gives us a limit of 5,000 micrograms instead of 11. And 11, as we said before, was probably too high. So it's 500 times higher. Actually, this would be clearly visible on the scoop. So the scoops could actually be easily visually inspected, and if there's no residue on it, no visible residue on it, they're safe to use. So dedication of scoops is actually not necessary. So using a science and risk-based approach, visual inspection only for scoops and similar utensils can easily be justified. Thank you.